Electromagnetic waves. Hello friends, in this video I will give you a basic idea of electromagnetic radiation, spectrum, examples and the types. Energy is a measure of ability to do work. It comes in many forms and can transform from one type to another. So in case of electromagnetic waves, the accelerated charged particles create electromagnetic fields when they move, and this field transport the type of energy we call electromagnetic radiation. Thus, we define electromagnetic radiation as the flow of energy at the speed of light through free space or material medium in the form of electric and magnetic fields. As per Maxwell equation for time-varying fields, a space-varying electric field produces time-varying magnetic field, and a space-varying magnetic field produces time-varying electric field. These time-varying electric and magnetic fields are mutually linked with each other at right angle and are perpendicular to the direction of propagation. An electromagnetic radiation is produced whenever a charged particle, such as an electron, changes its velocity, that is, whenever it is accelerated or deaccelerated, an EM wave is produced. A common example of this phenomena is an oscillating charge in a radio antenna. Electromagnetic waves are member of a family of waves having common properties called electromagnetic spectrum. Each type of wave in an electromagnetic spectrum has a different wavelength and frequency. Thus, an electromagnetic spectrum is a continuous range of wavelength or frequency. Depending on the wavelength and frequency, there are 7 types of electromagnetic waves. The EM wave having long wavelength, low frequency and low energy is called as radio wave, while the wave having short wavelength, high frequency and high energy is gamma rays. The type of radiation that occur in different part of the spectrum have different uses and dangers depending on their wavelength and frequency. The properties of EM waves are: they are transverse wave, that is, the acceleration of charged particles are in a direction perpendicular to the direction of propagation of wave. They can travel through a vacuum at a speed of light. Also, they transfer energy from one place to another place. EM waves have the property of reflection, refraction, diffraction, scattering and polarization. Depending on their frequency range, these EM waves have different applications, like X-ray are used in baggage scanner, radio waves are used for communication like cellular communication and telephonic communication. Microwaves are used for cooking and satellite communication. Infrared are used for electric heaters and night vision equipments, and also the TV remote control, where visible rays are used for photography and optical fiber communication. Gamma rays are used for killing cancer cells. For more detail, visit our website easyelectronics.co.in.